All right, so we're having a bit of problem with the slides, so I provided a PDF document, and usually there should be also something on the right border of that image, but I will try to mention what you usually could read there. So welcome to my talk, Into the Wild, with natural language processing and text classification. My goal for today is to give you a real-world example of a project that we are currently running internally. So it's kind of an experimental project where we want to optimize some things that we have to do in our internal work. So it will be interesting for you if you never worked with natural language processing and you want to get an idea how to deal with kind of these problems and how to model it. So I can give you how we managed it and which steps we have taken to build our models. If you're more experienced in natural language processing, I would really love to go into discussion with you, and so we can also take it offline afterwards and share experiences, because I think it's a super interesting field of technology. Okay, I'll wait a second. I think it's one of the problems never being solved, like getting presentations on a beamer. I think we will have like artificial intelligence in every form. It will replace us completely, but we won't get a presentation on a beamer. So we will never manage that. Well, it's okay. So you can just go into presentation mode. I think we will work with that. Oh, okay, over there. Yeah, it's fine. We will work with that. Also, the clicker is not working. Yeah. Okay, all right. So here we go. Who am I? Hi, I'm Peter Grosskopf. I'm a developer. So usually I'm coming from the Ruby world. So I started 2005 building applications with Ruby on Rails. So that's my origin. Worked as a freelancer for a couple of startups. Then I founded a software engineering consultancy in 2008. It's called Zweitag, and we were basically building applications for startups as a contractor and also for bigger corporations. We had 30 employees in the end. When I left it to move on to do something new, and nowadays I'm Chief Development Officer at HitFox, and I built there a team of 35 people, which is bootstrapping the prototypes for the new ventures that we found with the Company Builder. Yeah, and yeah, as I mentioned, or as mentioned in the introduction, HitFox is a company builder with, at the moment, I think 17 companies, and in the fields of edtech, fintech, and big data. And yeah, so we have 500 plus employees at the moment, so it's pretty big. And we as a company builder, so what is this exactly? To bring it on a very simple formula, because usually people don't really understand company builders, how does it work and how you're doing that and so on. I want to keep it very simple today. Company building is a mixture of ideas plus people. And especially when it comes to building something, the people are really the core element. And so for us as a company builder, it's a really crucial point to find enough people who can help us with building our companies. And so we built a strong brand, and we are pretty famous also or pretty well known in the startup scene. So we attract a lot of people, but that brings us to the real world problem that we want to solve, and it's we're receiving up to 1,000 applications every month. And so the big question for us was, okay, how do we handle to process 1K applications every month in the same way? And yeah, so there might be a couple of solutions. Of course, you can do it by hand, and this is also what we do, and our HR team does an incredible job there, and it works out pretty well. But we thought, hey, how can we support it, or how can we make it faster, or how can we improve the quality? And yeah, so there might be a couple of solutions, and we thought, okay, machine learning, might this be maybe a solution to work better? I have to admit, it's really not about, yeah, so we're tech people, we know how to use machine learning and all these tools, and this is why we're throwing this on a problem, and we're solving it with tech. And it's also not the intention to get rid of the HR people doing this. It's really more the idea that we want to support them doing their work, so that we just get a feeling for the problem situation, and we're running some experiments, how the data looks like that we get from our systems, and we're running some experiments to see how much we can drive it, and also to see if a machine takes a decision. Is it the same as the employee does? And if we get to this point, can this machine provide some kind of sort by relevance feature or something that the HR worker just takes like the next resume out of the application pipeline, sorted by relevance, so that we contact the important people faster and invite them faster to our job interviews. Yeah, so how did we build it? So let's go. So these are our action steps that we process. So first, you have to prepare the textual data. So yeah, and then you build a model to classify the data. You run it, and you display the results and interpret them. Yeah, in the preparation phase, first we have to load the data. In our case, we built a kind of a database where we have anonymized profiles in it. So because it's still in an experimental state, so we just want to play around with some data, and so we extracted the textual information from CVs, from curriculum vitae PDFs, and load them into the database. And we are kicking out outliers. So this basically means that, of course, we receive a lot of applications for jobs that are pretty important for us. For example, for co-founders, for developers, but also we have like smaller job positions where we don't receive so many applications. So we kicked out these ones because we want to have like a strong database. We're cleaning out stop words. So because these are, in the matter of analyzing a text, not that important. So for example, with and these kind of words, because they're come out pretty often in a text, but they're not pretty relevant for us. So we're kicking them out. We do a language detection, and this is from the principle behind it done by detecting or by counting the stop words and figuring out, okay, which likelihood, with which likelihood is it the English language or the German language? Because yeah, the stopped words are like unique for the specific languages. And yeah, then we also do stemming with natural language processing toolkit. So, which basically means if you have verbs or like terms in singular and plural, that you bring them on like a unique form, so that they equal each other. Then we define classes for the workflow states that we get out of our HR system, because this is important to let the system train. Because if you want to train a system, you have to give it feedback information, and in our case, it's so because we want to have enough also like true cases. It's did we invite a person or not? So this is like the 1 or 0, and yeah, and then we link all the data together. Yeah, how do we build a model? In our case, we started with a very simple one with the TF-IDF classifier. It's a bag of words model. TF stands for term frequency. IDF is the inverse document frequency. And yeah, so because we want to transform the textual information into quantitative information, because this helps us to do the calculations. And so this is done. For example, we have here this text. I am a nice little text, and we convert it into a vector. And in the last row, you see such a TF-IDF vector filled with information. In matter of the term frequency, we count the occurrences in the document, so that's pretty simple, especially with our example here, because we every word just comes once, so we multiply with a 1 here, and then we add the inverse document frequency, which means that we count how often a word comes within all the documents. And if we have here 2 documents, one, I play a fun game, and the second document, I am a nice little text, we can fill the numbers. So first we have the term frequency, so like we had an example before, and in the cases with I and A, these terms come up 2 times, and yeah, so which leads to the situation that in the last row we have 0 results there, which gives it like not so big importance. And this is also the idea behind that model, because if there's a word coming up pretty often, or like in all the documents, it's not really important because it's in all the documents. So we're really interested in the data that's unique for the documents. Yeah, bag of words, a pretty simple model. It's pretty easy to calculate, and this is also what I like so much about computer science. It's like a naive, intuitive solution. If you would have the problem, you would probably come to that solution. But the downside is that it ignores the contextual information. As you know, a language is a complex thing, and when I give you sentences, they have a meaning because there are words who have a context to each other, semantic information, and a bag of word model ignores this. So there's an improvement to this that are so-called n-grams, and an n-gram is a mechanism to build tuples out of the words that are right next to each other. So for example, if you have a sentence, New York is a nice city. You have New York, York is S. So you build combinations or tuples out of the two words that stand right next to each other. So it's an example for a 1 and 2 gram. So like, yeah. And if we take this vector, we can see here, for example, New York and is a. So these combinations really make sense. So these are like real combinations that would come up in a language, and where we have the situation that 2 words have a context to each other. So the next step we're doing is that we vectorize the resume. So we build these 1 to 4 grams in the application, and we're doing that with Skikit. So with a TD-IDF vectorizer, it's a Python library. And we define the runtime for our experiment. And this means that we have a couple of documents. We're sorting them by date. And we want to train on the basis of the older ones and make predictions for like the last 20%. Yeah, and we pick randomly out of the test group and yeah, do the predictions here. Yeah, then we run it. We do the classification, or we tested the classification with different statistical approaches. Also with the help of machine learning libraries. So there are quite a lot of algorithms that you can use. We used a stochastic gradient descent classifier and the logistic regression with the Python machine learning library. And we got in our model an area under curve of more than 70%. So that's quite a good model that we created here. We also played with other libraries, and yeah, but about the results I'm telling you a little bit later. So just a wrap up at this side. So if you're running a NLP project, what you have to do, so you prepare the data, you build a model, you run it with a library, and then you interpret the results, and area under curve is kind of the measure that you can use to say about the goodness of the model. Our conclusion was that after trying a couple of different approaches, so for example, we used doc-to-vec recurrent neural networks and a few others, and we found out that the simple approach is still the best one for us, and we kind of thought around it, so why is it like this? Well, our first explanation for it is that we deal with quite simple documents. So CV information, resumes are not stories, so there are not so many sentences that have so much meaning to each other. So it's just a listing. It's like a table, and these items don't have so much relationship to each other. So it really works with our really good with our back of words model. And yeah, what's the outlook for us? We're running this project now since 1.5 years, and of course kind of started from the ground, getting into natural language processing. What we want to do next is we want to build a better database, so also with more connected information from the systems and also from the data that we can get within the company. We want to experiment with new approaches, other algorithms, and also we want to tune our models. And if we are going to use it in a live environment, we are thinking about building a continuous learning model so that we kind of set up the model and that it continuously learns. Yeah. I don't know, so I used that metaphor like Into the Wild based on that movie. Maybe you have seen it. So maybe you know that the main character dies in the end of that movie. So I don't want to spoil here, but okay, now I did. Well, I did not die, and you also did not die, so we have a happy end here. Thank you.